Do you know how filament is made? We went on a day trip to find out, so you don't have to. Well, technically, we didn't have to either, but who could refuse a kind invitation like this? With the news embargo ending on the Creality M1, you might be curious how it compares to a real 15-meter long filament extruder system. Spoiler alert, Levi sure did not expect to be put to work at the spooling machine, but you'll see. Today we are pulling back the curtain on a secretive factory to see exactly what goes into a perfect spool of 3D printing filament. Stick around to the end to see if we can keep up with a high-speed extrusion line without breaking everything, and to catch the reveal of the massive haul of custom colors we were gifted to feed the brand new Sovol 6 or 7 color tool changer machine we hope to test when it finally comes out. This is gerGO, and welcome to gerGO Print 3D, our YouTube channel where we explore 3D printers, laser cutters, entry-level CNC, fun DIY projects, and lots of filaments, of course. As always, this video includes curated, translation-ready subtitles, detailed chapter markers, and multiple audio tracks to give everyone the best possible experience. Our adventure started with a 4-hour drive from our home in Budapest to Filamentree's headquarters in neighboring Slovakia. Justway graciously covered our travel expenses for this trip, and we will talk more about the incredibly cool metal parts they manufactured for us a bit later. As we flew the little Neo 2 drone over the facility and parked, we were struck by the story of this place. Filamentree didn't start out making filament. They actually started by 3D printing proprietary venting pipes and manifolds on a massive scale. But they kept running into severe quality assurance issues using other brands' materials. So they did what any rational, slightly obsessed maker would do. They engineered their own filament production line. Stepping into their print farm is intriguing. They have fleets of bamboo Lab A1s, magnatos, and a custom large format printer boasting the volume of a SV08 Max, but utilizing a drop bed architecture. The craziest part of the story is that they are all continuously fed by these massive 5 kilogram spools produced right in the next room. The recipe for perfect filament starts with the raw ingredients. Step 1 is thoroughly drying the granulate, because raw PETG is notoriously thirsty and will ruin a batch if it holds onto any moisture. Step 2 is mixing the base material with colors and additives. It is genuinely mind-blowing to see that a surprisingly low percentage of color pigment, sometimes just 2%, produces incredibly rich, vibrant colors like their signature reds. Looking at their display shelves, the lineup is vast. They formulate everything from colorful PLA Plus and standard PETG to beautiful silk variants. They even modify the surface quality of PETG with 5 to 7% additives to create that gorgeous matte appearance, though they are completely upfront that this makes the material slightly more brittle. Their true crowning achievement is their premium PLA Pro and their unique PLA Blaster, available only in shades of black, white and gray, which we will dive into shortly. Now for the real magic, the extruder. While the exact temperature profiles and nozzle sizes are closely guarded trade secrets, it is definitely not 1.75 millimeters, and the temperatures are not what a desktop printer uses. The extrusion speed and the extreme heat must be perfectly synchronized to establish a consistent diameter. But here's the biggest surprise of the tour. To cool this molten plastic down, it runs directly through a 2-stage cooling bath. Yes, submerged in water. There are air cooling methods out there, but Filamentree chose water for superior thermal control. How does water-cooled filament not end up wet? The truth is, the moisture is entirely on the surface. It doesn't get inside. As it exits the bath, the filament passes through a rigorous wiping station, including a high-powered blow dryer that aggressively strips every single molecule of water off the surface before it ever reaches the spool. Before we move on, if you are finding this factory tour as fascinating as the hyperdrive on the Millennium Falcon, and hopefully a lot more reliable, smash that like button. Subscribing to the channel is your only hope to not miss out on our upcoming massive multi-spool prints. Thank you if you did, and now back to the extrusion line. After drying, the filament enters an ingenious buffering system. It looks like a complex pulley maze, but we are keeping its true stressful purpose a secret for just a minute or two. From the buffer, the filament runs through specialized quality assurance instruments. This is where Filamentree adds their true secret ingredient, an obsessive level of care and attention. See, these sensors continuously measure the diameter along two different axes, while a dedicated color sensor verifies the hue. This isn't just real-time feedback for the operators. Every single measurement is stored in a database. When a spool is finished, a custom QR code sticker is printed, and customers can scan that exact spool to see its precise dimensional and color values along the whole length of the filament. Remember our Bible class kids in our recent video? They found this QR code by accident. Watch our video here. If the dimensions drift outside their strict plus or minus 0.02 mm accuracy for PLA or 0.03 mm for PETG, it is instantly downgraded to second-class material and sold at a hefty discount. Nothing is wasted, and that filament is still perfect for big cosplay projects which require heavy post-processing anyway. Some of the filament you buy elsewhere are to this level of accuracy. Finally, the filament reaches the spool station, and this is where Levy's training is put to the ultimate test. The extrusion process literally never stops, ever. Well, at the end of the workday or when switching material, but definitely not between spools, which are filled every few minutes. So when a spool reaches its set length, an alarm blares. Levy had to spring into action, thread the end of the filament, eject the full spool, and load a fresh empty one. Remember that buffer system? While Levy is scrambling, the filament is still pouring out of the extruder, and the buffer wheels start moving rapidly toward their end stop, storing the excess slack. He was literally racing the machine. Thankfully, he had about 90 seconds to complete the swap. The factory engineers told us it used to be a much more terrifying sprint with less than a minute on the clock until they smartly decided to double the amount of buffer wheels to give the operators a fighting chance. Once spooled, the material is labeled with its spool-specific QR code, meticulously bagged, vacuum sealed with a massive desiccant, and boxed up. That vacuum sealing is a sight in itself. It can seal a maximum of 4 spools at a time. During the tour, we had a chance to ask many questions. For instance, why don't they use cardboard spools? The answer is simple. Cardboard is basically a sponge for moisture, and modern plastic spools have far less friction in automated color systems like the AMS. We also asked about recycling. They have a massive, highly capable grinder, and yes, they absolutely do recycle their failed prints, but the input material must be completely dust-free and perfectly separated. PLA and PETG are a disastrous combination, we know. They simply cannot mix. You might have also noticed a lack of ASA, ABS or other high-temperature flexible in their product line. This is an intentional, health-conscious choice. ABS and ASA emit harmful VOCs like styrene, which are not only terrible for the workshop air, but hazardous for the printing community at home as well. Instead of subjecting users to toxic fumes and the need for high-energy heated chambers, Filamentree developed their PLA blaster. It is a completely healthy in-house recipe that delivers excellent mechanical properties, including impact strength and an incredible temperature resistance of over 90 degrees Celsius after annealing, but even around 80 degrees Celsius without. That's incredible for PLA. Maybe we can get Igor from MyTech Fund to test this. Are you curious about something we forgot to ask during the tour? Feel free to drop your questions in the comment section, and either we or the dedicated team at the factory will gladly jump in to answer them down below. That open communication is exactly why we are incredibly grateful for our friendly, almost family-like relationship with the team at Filamentree. Because of their premium quality, we will be relying on their materials for all our upcoming projects, including feeding that highly anticipated Sovol 6 or 7 color tool changer machine, or so we hear. Filamentree currently ships throughout Europe at surprisingly affordable prices. If you want to try their filament and let them know we sent you, check the affiliate link below for a sweet discount. As we were packing up our gear to say goodbye, our gracious host presented us with this big box of filament, but they strictly instructed us to wait until we got home to look inside. Before we tear into it, we have to note that one material we definitely don't expect to find in the box is aluminum filament. Our extruders certainly couldn't print it anyway. And this is why we are so grateful to JustWave for sponsoring this video. JustWave used advanced SLM technology, selective laser melting, to 3D print the custom aluminum rotary disc we discussed in our last 2 videos. The ordering steps on their website were brilliantly streamlined. We just uploaded our STL models, selected the SLM metal process, and had instant quotes. We will be showing exactly what these industrial grade parts are for in our very next project. Alright, so what's in the box? A spool of the bright red PETG Levi had a chance to help with, along with other fun colors, special colors of PLA Plus like steel blue and violet glass. We also get a chance to test the black variant of their staple PLA blaster, a roll of carbon fiber PLA, and more of that gorgeous matte black PETG. This haul is going to be incredibly useful, especially since due to popular demand, we are getting more Panda feeders from BQ. We will soon be able to show the complete auto refill setup for the Sovol Max, and maybe even our other Sovol printers if there is enough interest in the comments. For more information and how we fell in love with this jet black matte PETG, watch this video. And to see our original BQ Panda feeder installation, watch this one. No more excuses, go print 3D. Thank you for watching another gerGO Print 3D video all the way to its end. Stay colorful.